insight into the way in which scientific research going on now doesn't always result in people contradicting the Bible. There's times where it actually comes up and provides support. And I find that interesting. I look at the issues of how the Genesis account and the book of Job say things about the formation of the earth that can only be understood by divine revelation. They are things that the science community hasn't known till within my lifetime, sometimes a little longer than that, but maybe within the last, within, let's say, the period from World War II on. And there's something real interesting that focuses on the work of the first creative day. So I know we could read that, but can somebody read or quote from memory?
In the beginning, there was...
In the beginning? Yeah, that's good. God created
the heavens and the earth.
Okay. And the earth was without form and void. Darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. So, if we just focus on what that's saying about the geophysics of the earth, what does it say? I mean, we know, okay, first of all, let's start with the reality check that the sun was created. Okay, there's a lot of, in the pious rabbinical community and some of the Christian community, the sun doesn't get created till day number 4. Okay, no, the sun has to be there. The planets coalesce around the sun, and the inner planets are rocky, the outer ones are gassy, and the ones in between are icy, and that's the way in which it was actually understood before Brother Russell's day. So when he put out the photodrama of creation, that was already the geophysical model. And we start with the heavens and earth being created. The sun's there, but there's darkness on the face of the deep. So what does that have to mean about the atmosphere around the earth?
It's cold,
David?
thick. Oh, sorry.
Okay, good, go for it, Justin.
No, I'm just saying it's thick, like you can't see.
Yeah, it's got to be thick. It's got to be a real heavy atmosphere, one in which the clouds are so heavy that you can't even get light coming through, even though the sun's out there. Now, the other interesting thing that comes out of going back and reconstructing everything that was taking place, the sun at this time was faint. It only put out 70% of the luminosity that it does today. So you have the sun can't come through. It's obviously a real thick atmosphere. And we have one other piece of geophysical information that the second verse of Genesis tells us about the condition of the earth. There's only water. Okay, there's darkness upon the face of the deep. And as we're going to see in the Genesis account, we're not going to go into it here, but as we see the earth developing, the land doesn't actually emerge until later. And that is every aspect of what's in Genesis. We get into this discussion on the 24-hour day nonsense, okay? And it's like, well, if God is so powerful, don't you think he can do it in 24 hours? It's like, if God doesn't need to be in a rush and he likes things working according to his laws, he's not worried about working on your time scale, okay? A day means a period of time in which a specific act was accomplished. And so we're just looking at the first of those days, but I really thought that this is important because we find out one other thing. It says the Spirit of God is moving. Brother David.
Oh, okay, yeah, no, I see that, right in verse 2, yeah. I have a
Yeah.
question. Could I
Sure.
ask? Okay. The two things you mentioned, that's obvious. It was dark.
Yeah.
It was only water.
Right.
But you said that the sun was only 70% of intensity.
Well, that's not in the Bible.
No, I know that. I understand.
Okay.
But maybe that was in your article in the Herald. I don't know. But I don't remember it.
Yeah.
But can you say more about that? I was unaware of that.
Okay,
And how do you know how
the,
long ago this was to know?
Okay, so let me just talk about how remarkable our sun is. If you are to take a look at the Milky Way, there's 4 basic arms to it now. And probably in the early 1950s, there was an observation that our galaxy is the merging of 2 galaxies that has reorganized. It comes together, gravity moves things, and we're located we have 4 arms in our galaxy. We have now, through neutrino technology, been able to look at all 4 arms because previously we can only see the 2 arms that were on our side of the center of the galaxy. But what's important about that? Our sun is the type of star that comes closer to the center of a galaxy, and right now it's way out on the outer arm, far away from the center of the galaxy, where there's a lot of intense radiation and stars going nova, blowing up. Everything you see around you, everything you are, we are the ashes of dead stars.
Wow.
Okay.
That's a big idea.
Okay, and the way the science is going right now, the first, after what, everybody calls the Big Bang, when things cool down enough for the energy to actually coalesce and form matter, what do you have? You have hydrogen. Okay, you form protons, electrons, they combine to give you hydrogen. As the hydrogen clumps together, that forms early stars that burn out fast, go nova, and when they actually explode, that process generates additional heavy elements. And the next generation of stars that are helium-based, helium has an atomic weight of 4. And you have the stars that are working on what we call fusion reactions. 4 plus 4 gives you 8. That's oxygen. That's how oxygen starts to form in stars. You add on another 4, you get 12. That's carbon. So the next generation of stars starts to build up everything that forms carbohydrates, and we're mostly carbohydrates, but we need to have even heavier elements in the metals. And those form in the 3rd generation of stars. Our universe is believed to be 13.8 billion years old, and Uncle Jim agrees with me on that. And in this process, we're into the 3rd generation of stars, and our particular sun is what's considered high in elements greater than carbon, which means that to form that kind of a star, the scientists who work on the formation of stars recognize that it has to be formed closer to the center of a galaxy, and yet it's way out in an arm, How did that happen? Well, the Lord had two galaxies come together, and in the gravitational process, it threw our sun way out onto the edge. Our nearest neighbor star, which is really close, it's only 3.5 light years away, Alpha Centauri, is actually so small that it's just going to burn into a cinder. It's not going to nova or anything like that. So we're in a safe, protected place with the sun. Around the sun, you first start to get a disk. If you want to know, it was, I am so impressed with Brother Russell using the cutting edge science of his day when he presented the photodrama. And the science as that was presented continues to be the basic paradigm used up into our day, and of course things have gotten much more sophisticated. We have the inner worlds like Earth, and now it's very clear from our studies that Mars had flowing water at one time. Of course, because it's only 1/10 the size of Earth, it couldn't hold an atmosphere, and the water's long gone. But that's something that we've been able to see with the probe on the surface there. Venus is 90% the size of the Earth, but because it's so close, it's actually in a hothouse condition where temperatures are incredibly hot, and there's no water there. But the Earth is in a special habitable zone. And even though the sun was faint, the greenhouse effect at this point was so heavy, it was so pronounced compared to today, that you had liquid water, which is what the Bible talks about. Darkness, liquid water, and life. So how did the life exist without light? It existed on chemicals. The Earth was in a condition where the ocean was, there's debates, but it looks like the ocean was probably about 150 degrees centigrade. Okay, 100 degrees centigrade is 212 on the Fahrenheit scale. And so much hotter. And we know that today in areas like volcanic vents, we have life that can survive at 175 degrees centigrade. That was the sort of early life on an Earth that did not have an atmosphere we could even think of breathing. It would be a heavy atmosphere, very principally water and carbon dioxide, and in that atmosphere, what's the plan for turning this planet that does have water, which is important to life, and is at a point in the future going to have land emerge? What needs to be done so that we can start getting the Earth prepared for man? You need to have oxygen. And where does oxygen come from? I think we all know the answer to that.
Trees.
From trees. It comes from plants. So the thing that happens during the first creative day is you have the emergence of photosynthesis, but half of the life on this Earth doesn't depend on light to this day. We didn't know that until recent times. And by the way, the other interesting thing that comes out of this is very, very high radioactive environment in addition to everything else. You had a lot of radiation. So I'm going to just show you, and we're going to get to
I don't think that mouse works. Oh, you're using your finger, right?
Yeah.
You should be able to use the up and down arrows
Okay.
on the right side,
That sounds good.
or the left and right.
So, if you know, you go to Washington State, and that's a very, very active tectonic area because the Pacific plate is slowly turning at about the rate your fingernails grow. If you want to know what plate tectonics works like. And you have the ability to get into a safe deep diving zone. You can go down and see some of this sort of life that still feeds off of chemicals. What is it doing? It's feeding off of the metals that are coming up through the volcanic vents there, and then forming large towers in some cases as it takes those chemicals and actually uses them the way we use, you know, sugar to feed ourselves. And the question that those of us who believe in the Bible need to ask the scientific community is, how without inspiration did this detail that life could exist without life come to us? How did the Bible know that? It sure wasn't coming from the wisdom of the Egyptians, where Moses had been trained. It wasn't coming from Babylonian science. It had to come from divine inspiration. So I love this diagram. This is out of Nature magazine from 2014. And I'm laying out how the Genesis days line up against the geophysical record. What are we looking at here? This is one way using logarithms, and we don't have to talk about that, to show the atmospheric concentration of oxygen. And we go from an atmosphere with no oxygen to what's called the Great Oxidation Event. And that takes place during the first creative day. The Lord brings photosynthesis into the picture. There is light. When there's light, now you can have a whole class of living organisms that don't depend on feeding on chemicals. Things like iron and sulfur were used to supply energy to everything that was living, and like those vents at Juan de Fuca at the bottom, that's what they're living off of. And there's a massive change in the atmosphere that begins. But there's also some interesting pushback, because, you know, the way the Heavenly Father's wisdom has set up life, it actually regulates the planet. And this was noticed 100 years ago by a brilliant Russian scientist, Vladimir Vernadsky, who published a book called The Biosphere in Russian and French. And of course, this was right at the time of the emergence of the Soviet Union, in 1924, and nobody was really reading the Russian version. Very few people read the French version, and it just sort of sat there. But he noticed it, and then it didn't go much of anywheres. But what happened in the early 1960s was that the United States thought, well, we're going to send a probe to Mars to see if we can find life. And so they got the best scientists in the world for looking at the experiments that could detect the chemical byproducts of life. And this was a man who died at the age of 104 just about 3 years ago, named James Lovelock, in England. And they said, we want you to develop the life detection experiment. And he says, well, what do you want me to do? And they said, well, you know, you've got the funds, you've got the mission, go for it, you tell us what to do. And so he was an expert at building gas chromatographs, which are a technique that's used to separate out organic chemicals and actually say what they are. And he got into the question of what do I detect, and then he came to the same conclusion as Vladimir Vernadsky, which is that in the absence of life, there would be no free oxygen. Okay, that's 21% of our atmosphere that is important for us to stay alive. And there'd be no free nitrogen. So that takes up 99% of our atmosphere. Okay, so 99% of our atmosphere is only here because of life. And that is something that then got turned into a thought that, he needed to popularize this, and he called this the Gaia hypothesis, namely that life modifies its environment to keep it comfortable. And I actually wrote to Lovelock and asked him about the times of restitution, what he thought about that. And he actually wrote a note back to me, and this, it was really sweet. Yeah, and so I got a note back from a world famous scientist, and he thought it was a good idea. I just want you to know, he thought it was a good idea.
Richard, can you repeat the name of the Vladimir, the Russian guy?
Oh, Vladimir Vernadsky? Yeah, Vernadsky is in English Vernadsky. His son became a noted professor at Harvard. His son was a historian, but Vernadsky, Vladimir.
And the book he wrote?
It's called The Biosphere, and it was really fun because there was a noted scientist named Lynn Margulis who worked with a group to not only get it into an English translation, but to annotate where he was right and where he wasn't right. And he was right on most everything. And he has a really delightful little calculation that says if there weren't limits on bacteria, they would propagate at the speed of sound. It's like, really? That's kind of interesting. Yeah, he was brilliant, but not red. It was red. Well, James Lovelock rediscovered everything. So we're focusing on this first day, and here's the important thing for us. If you're going to have intelligent creatures, you're going to have to pass along a lot of information from generation to generation. And that means if you look at half the life on this planet, it's bacteria that we call prokaryotes. Karya means a kernel. It's used in the biology community to talk about the nucleus of a cell. Okay, so there's two types of cellular life on Earth. Half of it has DNA, but the DNA is spread throughout the cell. Those are called prokaryotes. And the ones that have the information in large amounts, and that everything we can see is a eukaryote. It has a nucleus and then a powerhouse that's called the mitochondria. And what's interesting is that, for example, we have 43 billion base pairs of DNA information in our nucleus. But if you get to the mitochondria, that's 27,000 base pairs. That's simple. The mitochondria supply the power. And why is this important? What happened during the first creative day? The Lord brought together two bacteria that actually complement each other. One of them, remember there's no oxygen at this point, one of them produced hydrogen, the other one consumed hydrogen. And so there's been a lot of interest in the last few years to look at the development of everything that forms the kind of life that we are and the kind of life plants are. And this is where things got interesting, because here's an article out of Nature magazine from 2 years ago. The Lost World of Complex Life and the Late Rise of the Eukaryotic Crown. Okay, so that's a bit of a mouthful. The group that Brock's led here, Professor Brock's, he's out of Canberra, Australia National University. And here's the interesting thing that comes right out of his article, and we had to splash this into Beauties and the Truth. You know, this came out in June, and the September issue was coming. It's like, Brother David is not only the reviewer, but he's also the one who gets everything set up. You know, Brother David, do we have a spot here where we can put in this little write-up on what the community's found? Because what would be one of the evidences of intelligent design that we could ask a scientific community about? What would you think, AJ?
The Fibonacci sequence.
Fibonacci sequence is certainly something that shows up in the growth of life. But in this particular case, I was thinking of what this particular group did is they would take the rocks from this early period of the first creative day, and they're analyzing the chemicals that they find in those rocks that are byproducts of life. And it turns out that, you know, I said there's two different types of cells. There's the prokaryotes, which are the simple bacteria, and there's the eukaryotes, which is everything else that we can see. And they leave behind two different signatures. In fact, the interesting signature I didn't know only eukaryotes leave behind, and they've been doing it since day number one, is cholesterol. Okay, so this group would take and analyze the chemicals that were available in those rocks, and they said, oh, these are from prokaryotes, these are from prokaryotes, no problem. And the difficulty that they have is the eukaryotes appear in the record, but there's 8 different families of eukaryotes that appear, and they're so diverse that this group under Brock said, you know, there's 500 million years of geological evidence missing. And where am I going to go? I was hoping to bring up my, I was hoping to bring the article up on my laptop, and I have it here, but I want to read you what they said right out of the article. Current ecological, he says, current ecological hypotheses do not explain the apparent scarcity, in other words, they can't find it, of aerobic eukaryotes, those are ones that breathe air, over a time interval of more than 500 million years. Now that's a long time even for geologists, okay, 500 million years. And across all environments where biomarkers are detectable, including apparently nutrient-rich and oxygenated habitats. And so basically, you know, Professor Brox throws up his hands and says, what's he talking about? He's saying that the eukaryotes, when they emerge in this period, and they're analyzing them now, are already so diverse that if, he says elsewhere in the article, even if you use the model for the fastest genetic drift, and what do I mean by genetic drift? Well, let's go back to when COVID was here. Okay, because the virus is actually not living, but because the DNA that forms the virus is so simple, it rapidly mutates, and we kept hearing about different versions of the COVID that were coming around, and creating havoc during the pandemic. And the viruses, because they're so simple, mutate very rapidly, but things like eukaryotes that have a lot of DNA don't mutate very rapidly, as we're looking at the record. And I just wanted to share that because how do you explain 500 million years of missing data? Intelligent design. So that's the only point I just wanted to share. It's something that is coming out. When I mentioned that the two cells that come together, the two cells that merge together by the activity of the angels, as far as I'm concerned, it wasn't random. Okay, they actually complemented each other, and that the evidence for that was actually just presented this month in Nature magazine, but I didn't even download that yet. So, to me, this is exciting material that helps us feel like, we're not just living back in the Middle Ages or in the Dark Ages by believing in the biblical account. And I just wanted to share that. That's it.
Thank you.
Thank you.
Okay. So let's in general, looking at everything in that Genesis account is of high interest to me. So I can take general questions, but let's just close with a word of prayer at this point, because I know it's been a long day for you. So let's see. We ask Brother David to open with prayer. Okay, Sister Marilyn, could you close with a word of prayer, please?
Holy Father, we're so thankful to be gathered together in your presence, and we're so grateful for the many ways that you reveal yourself to us, and for the wonder of creation, even though we don't even understand the half of it. We are thankful for the glimpses that you do give us. We ask that you'll be with us throughout the remainder of the convention, and please help us to take these things that we're learning and be able to share them with others and help it to transform our hearts and minds so that now and in the future that we can better serve you and others. And so we ask all of these things in Jesus' name. Amen.
And if you want a simple version of the article, that's Beauties of the Truth from September 2023. That's on the website.
Are there more slides you have?
Nope. Thank you.
Thank you.
Brother Richard, are you
You've got it all.
Are you I think he is. Hey, Brother Richard.
That got everything going when you had that those college connections.
That's right.
Brother Richard?
Hey, Brother Richard.
Yeah.
Are you open to public questions?
Brethren, AJ's going to direct you on what to do with the chairs, but Brother Richard Doctor has opened up.
Yeah, if anybody wants to talk about.
We need to get this room back into the original order, so AJ will help you with that.
I think Brother David has a question. Oh, sorry.
Sorry.
Oh, I'm sorry, what's the question,
If
brother?
five of us, including me, could just grab, one chair and then go to the next door when we get a chance.
And AJ knows how
Right
the
now?
tables go back.
Once we get an opportunity when.
We have almost the same bag. It's like that's not my bag.
It looks like it, doesn't it?
What was the question?
AJ, I'll take.
You talked about some period of time that's
AJ.
not reflected in the creation and
Yeah,
therefore.
yeah.
Explain more about it.
Okay, what they're basically saying is they looked at, they looked at the kind of DNA and activity of these 8 different families of eukaryotes. Obviously, we're eukaryotes, things like red algae are in a different family. Okay, that's the eukaryote, and then they had about 6, and I'm not sure if that families is the right term, or phyla, or whatever I should be calling them, or genus, or whatever, but these distinct lines were so different early on, and that they can't, it's like,
They can't develop.
you know,
one
yeah,
together.
it's like, where's the evidence is missing, and this is coming out of one of the top science journals.
What kind of animals are these?
Okay, well,
Eukaryotes,
we're
I have
one
no
of the
idea.
kinds of animals, but things like red algae are eukaryotes also.
Okay, but give me an example of something and then something else where there's no linkage between it. What do you, just trying to understand.
Okay, when you're looking at the fossil record from that period, because you're still talking about single-cell life, or just very simple multicellular life, you need a microscope.
Okay. you
And
have
as
that
soon
little
as they
small-
get the microscope, it's like, my goodness, that looks like red algae the way it is right now. And also as they start detecting these byproducts, because this is the really hot thing to do in the geophysics field for people investigating this. They go and they're looking at the chemicals left behind, which not everything degrades. So these get left behind and included in the rock, and they are absolutely from life because, you know, whenever something comes from life, not only is it a typical complex chemical structure like cholesterol, which continues with us, you know, to this day for good and bad, but they also, there's a signature to life in several different ways. The easiest one that was identified way back with Louis Pasteur is that if you shine a polarized light through it, it rotates the light one way or another way. There's a characteristic rotation for life, which is left-handed. But there's something more important than that, and this is that life is selective. If you look at the things like we have oxygen 16 and there's some oxygen 18. Both of those are stable isotopes of oxygen. And there's a natural abundance of those, but life selects for oxygen 16 and excludes oxygen 18. Life selects for sulfur 32 and excludes sulfur 34, and there's sulfur in every single cell in our body. And so they look for these types of signatures in the minerals, and you know, it's a direct evidence of life when they can see that. And they're seeing what the fossils look like, and they're already diverse. And this group says, hey, we know where to look, we know how to do the analysis, and we you know, there should be what they call the last eukaryote common ancestor. In the literature now, you have to know the acronym they're going to use is LECA. You know, they say, well, it has to have started as one cell and diversified, and there should be evidence for the branching out. They can't find it. They only find it fully, you know, fully operational.
Okay.
So that's interesting. Yeah, Thurgood.
So now that this foundation is established, where can we expect to go from here? Like,
Okay, where can we expect to go? Well, I think the important thing is twofold. First of all, I do not want to ever present anything that's not from the peer-reviewed science literature, because when I'm making the arguments that the Bible had to have had divine inspiration to know these details of geophysics, I don't want to go and say, oh, you know, here's something from a, you know, a creationist source. I like saying, hey, this is from the top science journal in the world by one of the most esteemed and studied groups in the world, you know, of scientists. And they're coming up and just saying, we don't know how to answer this problem. And 500 million years is a pretty long time. Now, the whole Phanerozoic is not even I'll say 500 million years. But where do we go from here? I think where we go from here is making sure that when our, older brethren or young people are confronted by issues of science and the Bible, that we bring out to them, when you ask, how did these geophysical details get done right in the Bible? Like land, first a world covered with an ocean, then land appearing, and there was an even more interesting, very, very interesting lecture at the University of Chicago in the end of February about how important the development of land when it came and the development of the atmosphere as it came affected the orbit of the moon, because the moon drifts away from us at a pretty rapid rate of 4.3 centimeters per century, and or per year. Per year. So over a century, it's actually a pretty good drift. So that's okay. So the moon gets about that much further away from us each century. And, the moon is critical to life on Earth. There is no other planet in this solar system that has the moon to planet ratio that's as big as our moon. And why is it important? It's because we're only 93 million miles from a major star. And that star sends off light, but it also sends off a lot of radiation in the form of particles. Sometimes those come down during intense storms as the aurora borealis. Okay, if those came streamed onto the Earth without, we have like a windshield that diverts them away from the Earth because of the Earth having a magnetic field. That magnetic field doesn't exist without the moon. Okay, the moon is responsible for the magnetic field of the Earth. The magnetic field of the Earth is responsible for protecting us from these cosmic, well, they're not cosmic rays, but from these, particles streaming off of the sun. And if they came in, there could still be life, but, our skin would be like the skin of a rhinoceros or something like that. And the Lord decided that our skin, with all its different shades, is prettier the way it is. And it really makes a difference for life on the, on the Earth. And it provides, it also provides for just some of the Lord's beautiful testimony to us, because we can see an eclipse. The moon is just the right size to eclipse the sun. Okay, if it was smaller, it not only wouldn't have enough tidal pull on the Earth to generate the magnetic field, but we wouldn't see anything like an eclipse. And I think some of us may have seen the solar eclipse just in April of 2024. Okay, I went to downstate Illinois so I could see it, and I knew there were brethren who were, going and watching it, because it's like, I've never seen a solar eclipse, and I'd like to see one. So it's things like that which just show the care and guidance. But what came out from pulling together all the work that now is taking place, we know the moon is the thinking used to be that because the Earth's core is mostly iron and nickel with oxygen, that generated a magnetic field from the core, and there's some accuracy to that, but for the most part the magnetic field is closer to the surface than previously had been thought, and it's there on the surface definitely linked to the tidal pull that the moon has on the earth. We see it, from the movement of the tides, but it's actually pulling on you and me and everything around, and it makes a difference across the whole planet. But the moon wouldn't be in its present, the moon had to form closer to the earth, okay? When the moon was first formed, the earth was hit by a planet that was the size of Mars, and the scientific community's given it a name. It calls it Theia, from Greek mythology. And that impact splashed off, mostly what was the crust of the Earth, and that coalesced into our moon. And so it was very, very important as soon as the Apollo mission was able to bring back moon samples to Earth and those got analyzed. It was like, oh my goodness, this is ancient crustal Earth material. Okay, because the competing theory when I was a kid, I went to the the Field Museum of Natural History in Chicago, and they still had somebody on staff there who thought the moon was captured gravitationally by just wandering around and moving too close to the Earth. But with now, some of the interesting evidence is we've actually been able to find additional parts of this impact that went out as far as the asteroid belt, and that's proven to be very interesting, along with looking down into the Earth. You can actually see the remains of the planetesimal the planet that smacked into the Earth to give it its present weight. So, and I just think that, as the prayer said, we only know a fraction of the wisdom and planning that went into giving us this beautiful, planet that is alive. And it was a lot of, it makes you appreciate not only the way in which the Heavenly Father and the angels create beauty, but it was a lot of very, very serious long-term planning, because you had to take the atmosphere, and as the sun was warming up, the atmosphere, you're trying to maintain water on the planet, so the atmosphere has to take out those greenhouse gases. And what happens, like if you come to Chicago, or anywhere between here and Niagara Falls, you have about 200 to 300 feet of limestone, okay, that comes from what I believe would be the third creative day, when land started to appear. And this particular limestone is carbon dioxide taken out of the atmosphere and converted into rock. Limestone is calcium carbonate, so it's calcium along with carbon and oxygen, Ca for calcium, and then 1 carbon and 3 oxygens. And all that was in the atmosphere at one point. Yes, Brother Todd?
So I have a question. There's a scripture that talks about the morning stars that sang together.
Yes.
And popular thought is that perhaps that was the
Logos and
Lucifer.
Lucifer.
And we think of Venus as the morning star. Was there maybe another planet out there that might have?
No, there wasn't another planet, because you can start now with a numerical simulation and show the inner rocky planets, and the one that maybe has the most variability is when you get out to the gassy planets like Jupiter. But when we get back into Isaiah 14, which I think has been quoted about 5 times during this convention, it speaks about Lucifer. And if you've ever taken a look, anybody taken a look at the Hebrew there for Lucifer? Okay, the Hebrew is halal, like hallelujah, It's not actually anything about daylight or light, because Lucia, it would be Latin for light, fair, to bear light. Okay, so literally Lucifer is the light bearer, which is tied in with Venus, as you say. But the name in Hebrew is actually praise. His name was praise. I think it's even worse to fall from that position of grace to where things are today. And the book of Job is one that I've been following with great interest. In this lecture on the moon, I was like, that lecture might actually help on Job, and it really did. As I traveled down to Hyde Park for that. The specific geophysical prediction of Job is that the oceans that we already have by the time we get to Genesis 1-2, that those oceans emerged as water from the womb. Okay, that, and there's two ways water can get here, because asteroids are water. Okay, those are dirty ice cubes. So it could be just asteroid material coming in from further out from the disk that coalesces around the sun into the planets, and supplying it, moving in and supplying the water. Or it could be something from within the earth. And the best geophysical theory that actually came out last year is that the water was generated within the earth by the reactions between the chemicals inside the earth to form the inner rocky planets. The first thing that happens, if any of you have looked under a piece of furniture that's on a wood floor or a tile floor, you can see what are called dust bunnies. Okay, okay, that's how planets start. That's how planets start to form. It's electrostatics holding it together, and then the dust bunnies get bigger, and eventually there's enough gravity to start pulling things in. And that gives you the inner rocky planets. The outer ones are what we call gas giants. So, to an observer from somewhere else in our galaxy looking at us, we look like a binary star system, because the sun, of course, has a radio signature, and so does Jupiter. Okay, Jupiter actually has metallic hydrogen on it. It hasn't lit off. It's too small to ever form a star, but it actually is big enough to have metal hydrogen under so much gravity that it's become a metal, and it emits radio waves on its own. So a radio astronomer, watching us from somewhere out there would think, well, we're like a weak binary star system, a very important star, and then a lesser one going around it. And the other important thing about Jupiter is that it gives us the 22-year solar cycle. Okay, because that's tied in, that's in resonance with the orbit of Jupiter. So
why is the 22-year solar cycle important?
I don't know, but it probably is. It's probably, our sun is just really beautifully regulated. It's considered metallic, it's unusually high in metals, which means anything heavier than carbon is considered a metal in the astrophysics community. And we were talking, Brother Obi talked about the Light Rider video that showed, so 8 minutes from, you would pass Mercury, you would pass Venus, and then 8 minutes out you get to Earth and the Moon just a few seconds later.
And 45 minutes later, you're still 30 minutes shy of Saturn. Getting to Mars. But this is amazing. I thought this was an amazing factoid. If you look at a
helium fusion reaction at the center of our sun, emitting a photon. That photon can only travel a short distance before it gets absorbed by, another helium atom, and then re-emitted, and then absorbed and re-emitted. And the calculation is that for a photon right at the center of the sun emitted to get to the surface, 10,000 years. Which is like, wow, I wouldn't have, I would have lost that one on estimate off the top of my head. But, to me, I spent a career in research and science, and and the lab director said, we're doing what we love to do, and we're getting paid for it. I mean, what could be better? And the tutorial in geophysics was real interesting because my former boss, his roommate at Cornell ended up being the director for Basin Exploration and Technology for Texaco Oil. And so he talked to my boss, Marty Perlmutter from Texaco, talked to Jim Frank, my boss, and said, I'd like Argonne National Lab to do a simulation of where the continents were during the Permian. That's when dinosaurs came. That's the fourth creative day, I believe. And that's when most of our oil was formed, because he believed that the orbital cycles of the Earth were the reason that oil is laid down in strata. So Marty Perlmutter is actually the one who started the geology community working on the oil industry to talk about cyclostratigraphy. And so there was a team that was pulled together of somebody looking at the position of the continents, the oceans, running a climate model, and then on top of that adding in the orbital cycles, the 4 orbital cycles that are called Milankovitch cycles. And then Jim Frank got a better job in Washington and left, and they, it was like, out of self-defense, I put my name into the hat for, becoming the group manager, and that happened. And it's like, okay. I managed a group of 37, researchers.
The doctor did it in the lab with the book.
Well, all of a sudden, here's this wacky project. It's like we're doing we're doing an initial simulation of how oil fields got laid down during the Permian, and so the first guy doing it got hired away by Saudi Aramco to do that kind of work for them. The second guy was absolutely delightful because he came from a very conservative religious Baptist family, and now he was working on climate simulations that were a lot longer than 6 creative days. Okay, and he had a site on creation and evolution, and when I wrote the first article for the Herald, I had him review it, and he was happy to do it, and I said, we need to contact the other researchers we're working with. We had a professor from Purdue who was the NASA specialist on Milankovitch cycles. University of Chicago was the specialist on position of the continents. University of Wisconsin and Northwestern University were working on the oceans. And University of Illinois Chicago was working on the biological activity. And so I would drag this guy out of the office, to go to the geophysics lectures for like 3 years while the project went on. And I got a real good geophysical tutorial from that, and I love it because it really shows the light that is in Genesis. And by the Lord's grace, someday I'll maybe be able to, pull all this together. I've only done a couple articles for the Herald, but
we should do a whole issue. I'll work on a whole issue with you if you want.
But this stuff on the first creative day and everything, it's in just, and the second creative day where Earth was in a crisis, because it could have gone into a runaway greenhouse like Venus, or it could have frozen. And life, and I love the first journal article that came along on this, popular journal article says, the emergence of life just at the right time was, quote, a lucky fluke.
The beauties of the truth.
Yeah, it was a lucky fluke that life came along just at the right time to adjust the atmosphere, because, you know, we got to go back to Vernadsky and Lovelock on this stuff. And, you know, to me, it's exciting. I love it. I don't get paid for it anymore, but that's okay. I still love doing it. So, thank you. You've been really good.
Yes, thank you.
Thank you.
Should we move these tables?